Hi, everyone. Thank you for joining our webinar today on running high-performance databases on Amazon EC2 and Amazon EBS. My name is Arun Sundaram, and I'm a product manager on the AWS storage team. And I'm joined today by my colleague Deepak Singh, who's a product manager on Amazon EC2. If at any time you have questions, please go ahead and submit your questions on the panel on the right-hand side, and we'll be sure to get to as many questions as we can at the end of the session. If there are any questions that we can't get to, we'll be sure to follow up with you offline, so please submit your questions. So what are we going to talk about today? The first thing we're going to go over is an overview of a few new capabilities that we've launched just in the last month around running high-performance databases with Amazon EC2 and Amazon EBS. Namely, these capabilities are Provisioned IOPS volumes for EBS and Hi1, our Heiio Instance family for Amazon EC2. We'll talk about these capabilities, and then we'll also talk about how you can choose the right offering for your database workload. And then we'll provide you with some resources to go ahead and get started. But before we jump into these new capabilities, I first want to cover a quick overview of Amazon EC2 and our Amazon EBS service. So Amazon EC2 and Amazon EBS are offered in a number of locations around the globe today. Amazon Web Services has 7 public regions. We have several regions in North America. We have a region in South America, one in the EU, Singapore, and Japan. And we also have a GovCloud region as well. Within each region, we provide a number of availability zones, or AZs. An availability zone is a distinct location that's engineered to be insulated from failures in other AZs. And they provide inexpensive, low-latency network connectivity to other AZs in that region. So you can, when launching an Amazon EC2 instance in an availability zone, you can utilize separate AZs to protect your applications from failure in a single location. So what is Amazon EC2? Amazon EC2 provides resizable compute capacity in the AWS cloud. It enables you to elastically scale up and scale down the amount of compute resources that you need to run your workload. And you can do this based on the demand internally within your organization or based on the demand of your customers. It allows you then to avoid the large capital expenditures that typically come with purchasing hardware infrastructure, because you only have to pay for what you use. The Amazon EC2 compute instances are fully under your control. So you're given an instance with a base operating system, whether it's Linux or Windows, and you can configure the instance as you need with the applications that you need to run. We provide full flexibility by providing not only a number of different operating system choices, but also allowing you to tailor your application to the instance that you need based on the cost. So you're able to, for example, spin up an EC2 instance with a low amount of CPU or a high amount of CPU, or there's also options for different memory allocations to the instance as well. This flexibility then allows you to lower your cost, again, to tailor against your particular workload requirements. In terms of pricing, we offer a number of different options. So we offer on-demand pricing for EC2. We also have a model called reserved instances, or RIs. RIs allow you to purchase a number of instances up front and reserve instances up front, allowing you to then pay a lower hourly cost when you actually need them. And finally, we have spot instances, which allow our customers to bid on unused EC2 capacity and run those instances for as long as their bid price exceeds the current spot price. Spot instances are really ideal if you have flexibility in when your applications can run, and they allow you to significantly lower your costs. Amazon EC2 is designed for high reliability, and it's backed by a 99.95% availability SLA. The next service I want to cover today is Amazon EBS, or our Elastic Block Store offering. Amazon EBS provides block-level storage volumes for use with EC2, providing low-latency access to your applications running on Amazon EC2. EBS volumes persist independently from the instance. So if you terminate your EC2 instance, your volume will continue to persist. They're easy to use, so it's as easy as creating an EBS volume, specifying the size of that volume, and attaching that volume to your instance. We allow you to flexibly provision these volumes is you can spin up a number of EBS volumes, attach them to your instances. You can then detach those volumes and attach them to other instances that need access to that data. Like our Amazon EC2 service, with EBS, you only pay for the resources that you need, and EBS offers a high level of reliability, 99.5 to 99.9% durability. EBS also provides you with the capability to take point-in-time backups of your EBS volumes and store those snapshots in Amazon S3, our durable internet storage service. You can then access those snapshots in subsequently creating EBS volumes from those snapshots. So now that I've given an overview of our EBS and our EC2 services, I'd now like to get into some of the capabilities that we've launched in the last month. The first capability I'd like to cover is what we're calling EBS Provisioned IOPS. EBS Provisioned IOPS is a new type of volume that we introduced several weeks ago to deliver predictable high performance for your I/O-intensive workloads. The way a Provisioned IOPS volume works is you create an EBS volume, you specify the size of the volume that you want to create, and you specify the number of IOPS that you want to get from that volume. And EBS will, for the lifetime of that volume, deliver that level of IOPS to your application. You can provision a volume for up to 1,000 IOPS today, and we'll be increasing that limit over time. And you can then attach multiple volumes to your EC2 instance and stripe across those volumes to deliver thousands of IOPS to your application running on EC2. The important thing to note is not just the level of IOPS that you're going to get from your volume, but also the consistency in those IOPS. So we've spoken to a number of customers who have told us that for their random database I/O workloads, it's not only the scale of IOPS that's important, but also the consistency at which they get those IOPS to their application, the consistency in the latency performance. And so Provisioned IOPS is really designed to deliver that consistent level of performance. You can use our Amazon CloudWatch monitoring service to monitor the metrics of your volume, whether it's throughput, bandwidth, latency, on a 1-minute basis, to really allow you to react to any changes in your volume performance. I'd like to give an overview of our Provisioned IOPS offering and compare it to our standard volume offering, just to give you additional context on when you'd want to use one type of volume versus another type of volume. So standard volumes, our pre-existing volume type, are really designed for applications with moderate or bursty I/O workloads. So for example, boot volumes are a great use case for standard volumes. EBS provides the ability to create a bootable drive for your EC2 instance. And for these bootable drives, when you're starting up an EC2 instance, there's typically a burst that occurs from the volume at runtime. So boot volumes are a great use case. Standard volumes on average deliver about 100 IOPS for customer workloads, and they provide a best effort ability to burst to hundreds of IOPS. Our Provisioned IOPS offering, as I mentioned, is really designed for more I/O-intensive workloads, such as databases, and it's really around providing consistent high performance. As I mentioned, you can provision up to 1,000 IOPS today, and you can stripe across multiple volumes to deliver thousands of IOPS to your EC2 instance. I'll now cover some things you can do to optimize your Provisioned IOPS volume performance for your database workloads. The first thing you can do is utilize EBS Optimized Instances. So EBS Optimized Instances is a new feature that we came out with in conjunction with our Provisioned IOPS volume announcement. EBS Optimized Instances allow you to fully utilize the IOPS that you provision on an EBS volume. So they allow you to create an EC2 instance that delivers dedicated throughput between your instance and your EBS volume. These optimized instances today are offered on M1 large, M1 extra large, and M24 extra large instances. We'll be supporting additional instances over time. The M1 large delivers 500 megabits per second dedicated throughput between your instance and volume, and the M1 extra large delivers 1,000 megabits per second. So an example of why you might want to use an EBS optimized instance. Let's say you're using, your workload is utilizing the Provisioned IOPS volume, and you're reading and writing from your application to your volume. And let's say you're also sending data over the network to your EC2 instance from another location. You don't want that data transfer to your EC2 instance to impact the performance and throughput that you're getting between your instance and your EBS volume. So by utilizing this dedicated throughput between your instance and EBS, you can ensure maximum consistency in your workload running on EBS. And so that's why when attached to EBS optimized instances, provisioned IOPS volumes are designed to deliver within 10% of the IOPS performance that you provision, 99.9% of the time. So if you've provisioned an EBS volume for 1,000 IOPS, you'll get at least 900 IOPS from that volume 99.9% of the time. The next thing to consider when utilizing a provisioned IOPS volume is the I/O size of the reads and writes that you're performing to that volume. Provisioned IOPS volumes are designed to process reads and writes in I/O sizes of 16 kilobytes or less. So if your application is reading and writing data at I/O sizes of 4 kilobytes or 16 kilobytes, and you've provisioned a volume for 1,000 IOPS, you'll get consistently 1,000 IOPS from that volume. If your application, on the other hand, is reading and writing data at 32 kilobyte block sizes, then you'll on a consistent basis get 500 IOPS from that volume. And the reason is because when EBS volume receives a 32 kilobyte block size, it splits that up into 16 kilobyte blocks and processes each of those blocks independently. You can utilize Amazon CloudWatch's 1-minute metrics to monitor throughput, to monitor the I/O sizes. What we've typically found is that random database workloads typically operate at an I/O size of 8K, 16K, 4K. But it is something to be aware of. Another thing to be aware of when utilizing provisioned IOPS volumes is to ensure that the queue length or queue depth meets the requirements of that volume. So a queue length is the number of pending I/O requests from your application to your volume. Many times you can configure your database to the queue length that you need. A provisioned IOPS volume must maintain an average queue length of 1 for every 200 IOPS you provision. So for example, if you provisioned a volume for 1,000 IOPS, then you'd want to have a queue depth of, on average, 5 per minute. And again, you can use CloudWatch to monitor the queue depth. This really ensures that the EBS volume, in order to deliver on the IOPS that it's been provisioned for, it ensures that it's getting the necessary I/O requests from your application to do so. A couple other things to keep in mind. When you're taking a snapshot, this can impact the rate of IOPS you're getting from your volume while your snapshot's pending. And then finally, for newly created volumes, you want to warm up your volume first before you place it into production. So for example, if you're running a benchmarking application to try out provisioned IOPS volumes, you may want to run your benchmarking application first to just read and write all the data on your volume to warm it up, and then run it for real. On the subject of benchmarking applications, we've actually gone ahead and put together a benchmarking guide that you can use in evaluating the performance of your provisioned IOPS volumes. So we spoke to a number of customers and got some typical benchmarking applications that they use when wanting to simulate database workloads. And so these are FIO, Oracle Orion, SQL IO, and we've gone ahead and put together a guide in our documentation. The link is here. It can also be found in our documentation, and we'll be sure to post these slides following the presentation. The guide walks you through setting up an EBS volume, striping to an EC2 instance, and it also shows you how to configure the benchmarking application to truly simulate a random database I/O workload. If you have other benchmarking applications that you prefer to use, please communicate that to us on the AWS forum. I imagine that we will expand the benchmarking apps that we talk about over time, and so the more we hear about the benchmarking apps that are commonly in use, the faster we'll provide that information to you. On the subject of the benchmarking guide, we did have one customer, Stratolux, test it out, and they were kind enough to share their results with us. So Stratolux, they builds and manages tailored cloud solutions for their customers. And they found that for their customers' database applications, throughput consistency is critical for their customers. So they tested provisioned IOPS, and they compared it to standard EBS volumes, and they posted a blog post on their website. So I highly urge you to go to Stratolux's website and take a look at their blog post on provisioned IOPS volumes. I took this chart from their blog post, and I think it's really cool and actually very informative as well. So the lines in blue represent the provisioned IOPS performance that Stratolux saw. On the left-hand side, the graph shows the number of IOPS that Stratolux saw, and on the bottom, it's the different workloads that they ran. So for example, if we look at the random read workloads, the random read tests that they did, if you look at the lines in blue, they consistently saw 7,000 IOPS delivered from their EBS volume. So the important thing to see from their EBS volumes, I should say, so they stripe multiple volumes to their instance. The two key important things to call out here is not only the level of IOPS that they were able to get, but also take a look at the consistency at which they were able to deliver those IOPS to their application. But again, I urge you to take a look at their blog post on their website. It's very informative. I want to talk a little bit about how we price for EBS. So EBS is similar to our EC2 instances. It's similar to our other AWS services in that you only pay for the resources that you utilize. The prices you see here represent our US East region. Our prices do vary based on the region that you're provisioning your resources. If you look at the US East region, our standard EBS volumes are priced at 10 cents per gigabyte that you provision in a month. And then they're also priced at 10 cents per 1 million I/O requests in a month. So for every 1 million read or write requests that you send to your EBS volume, you'll pay 10 cents. Our EBS provisioned IOPS volumes are priced at 12.5 cents per gigabyte month of provisioned storage. And our IOPS for provisioned IOPS volumes are priced differently than for standard volumes. So with provisioned IOPS volumes, you pay 10 cents per provisioned IOPS month. And so what that means is if I provision, let's say on the first day of the month, I provision a volume for 1,000 IOPS, and I use that and I have that volume for the rest of the month, I'll pay 10 cents times 1,000 or $100. Instead, let's say I provision a volume on the first day of the month for 1,000 IOPS, and I only keep that volume around for half the month. In that case, I'll pay 10 cents times 1,000 IOPS times 50% of the month, which is $500. Finally, the last charge on the EBS rate card is for snapshot storage. So in the US East region, we charge 12.5 cents per gigabyte month of snapshot storage in Amazon S3. And it's important to note that snapshots are differential. You can find out more information about pricing on our website. We also have an AWS calculator that allows you to walk through various scenarios. I mentioned EBS optimized instances. So the way EBS optimized instances are charged is based on the instance itself. So today we support 3 optimized instances, M1 larges, M1 extra larges, and M2 4 extra larges. And they're priced based on an additional hourly surcharge. So with an M1 large, if you configure it to utilize EBS optimized instances, you'll pay a 2.5 cent per hour additional surcharge. And you'll get 500 megabits of dedicated throughput to your application. So again, these are the instances that we support today. We plan on supporting additional optimized instances over time. It's important to note that you can use these optimized instances not just for your provisioned IOPS volumes, but they'll also deliver dedicated throughput to your standard volumes as well. So we have a number of customers today running EBS optimized instances for their standard EBS volumes as well. And I urge you to go to our forum and submit any other requests for any other instances that you'd want us to deliver optimized instances for. It'll help us prioritize that support. Finally, to get started, it's as easy as going to our management console, creating an EBS volume, specifying the size of the volume, specifying the volume type, so in this case, provisioned IOPS, and specifying the number of IOPS that you want to get from your volume. So with that, I'll go ahead and hand it off to my colleague Deepak Singh. And Deepak will talk about our Amazon EC2 Heiio Instance offering.
Thanks, Arun. So as Arun mentioned earlier, I'm a product manager with the Amazon EC2 team. And what I wanted to talk to you about was another way of getting lots of I/O for your databases on Amazon EC2, specifically our recent EC2 Heiio instances. So what are Heiio instances? They're a new EC2 instance type. They're actually our 14th instance for EC2. And our goal when we stepped back and thought of what we wanted to deliver was the ability to have a lot of IOPS. Specifically, we wanted to be able to serve over 100,000 random read IOPS, or at least be able, or around that number. And we also wanted to do it with very low I/O latencies. And in order to do that, the best way to do so is using SSDs. And so these are the first SSD-backed EC2 instance as well. Very quick on the specifications. The CPU is a hyper-threaded CPU. So you have 8 cores and 8 hyper-threads, for a total of 16 vCPUs that give you about 35 EC2 compute units of compute power, over 60 gigs of RAM, 2 1 terabyte SSD backed storage volumes. So you have 2 volumes each of a terabyte, and they're backed by a solid state disk. I'll talk about the storage I/O in a little more detail in a few seconds. The network I/O is the same as our cluster instances, so you're on a 10 gigabit Ethernet network, and you have support for cluster placement groups. So you can cluster high I/O instances together into a cluster as well. The platform is a 64-bit platform. We support both paravirtualized and HVM armies, and you're required to be running EBS-backed armies, and we call this the HI1.4 extra large. The main feature of these instances, other than reasonable compute power and the networking, is the storage I/O performance. So we benchmark this for Linux PV armies at about, you should be able to deliver, depending on how you set up your applications, 120,000 IOPS or higher for 4K random reads, and 10 to 85,000 write IOPS. And the variation in write IOPS depends on your active LBA span. It's a feature of SSDs and how your write performance functions as the amount of spare capacity on your disk changes. And I'll talk a little bit about how you can use that in benchmarking as well. For Windows and HVM armies, then those numbers are a little lower, but still close to 100,000 for your reads. You get very good sequential I/O performance out of these instances as well. For reads, you should be doing 2 gigabytes a second, and for writes, over a gigabyte a second as well. Quickly on pricing. So the pricing for these instances, and I'll just go over this very quickly. For Linux on-demand instances, you start at $3.10 an hour in our US East region. We also have these in our European region as well, where they're a little more expensive. You can get all the details at the URL on this slide. Like all other EC2 instances, we support reserved instances as well, where you have you pay an upfront fee for a lower hourly rate, and the higher utilization, the lower your effective hourly rate. So if you're running 24/7, we recommend using heavy utilization RIs, where you get you'll be essentially, if you're running 24/7, you're at roughly about 90 cents an hour for this instance. Windows pricing is a little higher and is listed here as well. This is for US East. The kind of applications that we recommend for these instances are essentially applications that require very high random I/O performance, especially if your read performance requirements are very high, because those are fairly consistent. And if your applications require 75 to 100,000 read IOPS, definitely this is the instance that you want, especially if you have very low latency requirements, the kind of latency requirements that are best served through direct attached disk. Because these are Amazon EC2 instances and your storage is instance storage, which means that if your instance is terminated, your storage goes away. We recommend that you use some form of resilient or replicated database architecture. So something like Cassandra is excellent for high I/O instances because you can replicate, you get good replication in your database, you're resilient to failure. But there's a number of applications that are well suited for these. We have had customers run MongoDB with quite a bit of success, key value stores like Membase, a bunch of clustered databases and analytic systems also as well, and we're looking forward to seeing what else people use these databases, these instances for. I wanted to talk a little bit about benchmarking. What you see in this slide are the numbers that you saw earlier from us on the specifications. These are the kind of setups that we use for when we were running FIO on these. So these are recommendations on how, if you wanted to benchmark and potentially replicate what we got with a well-tuned army with a new kernel, this is what you would get. So you should use your scheduler details. You should use, because the I/O rates are very high, we recommend a reasonable I/O depth, 32 or higher. We also recommend that you treat the 2 individual volumes as 2 disks for your random read and write operations. We are using a block size of 4. We typically benchmark at various block sizes, but we specify the 4K block size. If you really want to do parallel I/O testing, because you have the CPUs exposed to you and we're giving you all the threads, you should pin your tasks to the different CPUs, so each volume should be on a different processor. That gives you the best performance. And for random writes, if you want to capture the effect of write amplification, we recommend actually a ramp time of at least 10 minutes. And if you want to get the most, it's what I call a toxic workload. You want to get at the lower end of your write performance. You want to write for a little bit of time and take up spare capacity to see what happens. Again, if you're using SSDs, and I experience with using SSDs, this is something you're probably doing already. And we recommend initializing reads with a write task on both disks with uncompressed data before you start your benchmarking. A couple of useful resources for you to consider as you go along this path. There's a nice general purpose article on the register about SSD performance testing. And there's a paper from Microsoft Research which they published at a Usenix conference a few years ago, which goes into some depth on SSD performance and SSD performance testing. They're good resources to go to if you want to read up more on how solid-state disk should be benchmarked and how it behaves, because they're not exactly hard disks. Moving on to the customer side, most of you have probably seen this blog post, and there's a very nice presentation that Adrian Cockcroft from Netflix gave at a Cassandra conference recently, where they tested out their previous configuration, which is to the left in this figure that you're seeing, which was a Memcache-fronted 48-node Cassandra cluster. When they move to SSDs, they actually get rid of the Memcache layer, and they reduce the size of the cluster from 48 nodes to 15 nodes of the Hi14 extra large instance to get the same throughput. So what they found was that using the SSD-backed instances, for the same throughput, they actually lowered the system cost by about half. As I mentioned a few times, one of our goals is to have very low I/O latencies. So their mean read request latencies go down from 10 milliseconds to 2.2 milliseconds, and the request latencies at the 99th percentile go from 65 milliseconds to 10 milliseconds. So you get very good low latency I/O, and you can drive a lot of throughput. And Cassandra is particularly interesting because you get good random reads, and you can do almost serialized writes, which performance is really nice on these disks. This is one of the pictures from a live demonstration on a completely untuned system that Adrian did at the Cassandra conference that shows the M24 extra large and a high I/O instance. You can see the nice read scaling and write scaling on these. And there's a number of slides that show you key properties. So I really recommend reading both the blog post and looking at the slides from the presentation. We get some really nice MongoDB performance as well. So this is testing on a high I/O4 extra large instance. Here are your parameters, and as you can see, you can drive 64,000 Mongo ops on this instance with very low variability and throughput at about almost 250 megabytes a second. Again, so as mentioned before, this is a great platform for running not just Cassandra, but Mongo and other analytics systems which have high transaction rates. And we've seen customers run very successfully. And moving from M24 extra large instances or EC2 instances for these very high random I/O workloads. And it's been functioning very well for a number of customers. So some additional resources before we jump into our Q&A session. You can go to the EC2 instance documentation with the advent of both the Provisioned IOPS instance volumes as well as the Hi1 instances. We added some more additional information on how you should think about storage with EC2 as well, and I would recommend reading both these guides. Very quickly, I wanted to talk about database offerings that we have at AWS. We have a number of new features, as you just heard about, that support databases. So one of the first questions that we get from customers is, which offering should we be using for our databases? Should we be using the Provisioned IOPS volumes, or should we be using high I/O instances? If you have databases that require tens of thousands of random IOPS, as I mentioned, 50, 60,000, over 100,000 read IOPS, definitely high I/O instances are very, very compelling, especially if you are able to manage your own resilience or use some kind of replicated database architecture. Those are the use cases for which we would recommend high I/O instances. They're very, very cost effective from an IOPS perspective. Provisioned IOPS volumes provide you with a lot of flexibility because you can scale their size. They're suited for databases that require up to 10,000 IOPS, which is probably the vast majority of systems out there. And you don't have to worry about resilience. You don't have to worry about making backups and snapshots. That's all handled by EBS for you. We also have other database offerings. So if you're running your own NoSQL style database or transactional system, you should, the Heiio instances are ideal. If you want to not have to worry about any of that, you want to use a managed database service that delivers hundreds of thousands of reads and writes, and which you can tune. Amazon DynamoDB is also available. It handles things like cross-AZ replication, hardware failure, all the manageability. You don't have to worry about any of that. Just figuring out your queries and your code. And we also have a managed relational database service that supports MySQL, Oracle, and SQL Server. That's Amazon RDS. Once again, they take care of the cross-AZ replication, failover, backup, software patching, and recovery. So you can choose between running your own database on EBS and EC2 or using Amazon RDS. So we give you the full spectrum ranging from manageability and performance, and it's up to, depending on your needs, you have your choices available to you. And we are constantly interested in figuring out what else you're interested in. And so if you leave feedback in the forums or talk to people in your, say, account team, that's great feedback for us to continue to evolve our database offerings. Going back to the final steps, you have the EC2 detail page and the EBS website, which you can get more information on what features we offer. And if you want to get started, you're a command line or management console away, which you can get to from the URL below. With that, we'd like to spend at least 15 or 20 minutes taking questions, and we shall do so right now.
So the one question was whether we'd be supporting C1 extra large EBS optimized instances. And as I mentioned, today we support, just to recap, M1 large, M1 extra large, and the M2 extra large instances. And we definitely will be looking at supporting additional instances. So this is a great point of feedback on the C1 extra large. And again, just to reiterate, please go to our forum and request what type of instances you'd want us to support, and we'll use that to prioritize. Just some maintenance. Somebody had asked about whether the slides and the presentation will be available later. And yes, we will plan on posting the recording of the presentation and the slides. We'll hopefully get it up in the next few days or so. So that will definitely be available. Another customer asked whether RDS plans on supporting provisioned IOPS. So at AWS, it's really important for us to ensure integration between our services. And with that in mind, we are working on delivering provisioned IOPS for RDS, and we expect that to have that out for you in the future. I would say if that is a capability that you're interested in, please go ahead and let us know on the panel there, and we can go ahead and get in touch with you afterwards with any additional information. So again, if you're interested in RDS support for provisioned IOPS, go ahead and submit that to us on the panel, and we'll follow up with you. Let's see. So another customer asked whether optimized instances are going to provide dedicated bandwidth to our standard volumes, and yes, they do. So we actually have a number of customers today that are not only using optimized instances for their provisioned IOPS volumes, but for their standard volumes as well. And really, what the optimized instances are providing is consistency at the EC2 level, right? So they're delivering dedicated throughput between your EC2 instance and your EBS volume, and your application will benefit from that dedicated throughput, whether you're running on a provisioned IOPS volume or a standard EBS volume. So those instances are available for your standard EBS volumes.
So there's a question on when will Heiio instances be rolled out to other regions, specifically Asia Pacific. As of now, we are available in US East and Europe, but definitely we plan to expand out to other regions over the next several months. If you have any specific region requirements, I presume APAC means Singapore or Japan, please let us know. We'd be very interested. Reach out to your account contacts there, or leave your contact information, and we'll get back to you to try and get more information on what specific needs do you have. There's a follow-up question on the Linux distribution and kernel version that was used in the RAID 0 ephemeral benchmarks. I will confirm that and get back to you. I believe we used both the latest Amazon Linux AMI and Ubuntu 11.10, if I recall, with the recent kernel. I do not know the kernel version. I can look into that.
So another question was, what happens if I use a provisioned IOPS volume without using an EBS optimized instance? So if you use a provisioned IOPS volume without an optimized instance, you'll still get the high performance that a provisioned IOPS volume delivers, but you won't see the same level and the consistency of that performance. So as an example, if you're running an instance that's not optimized for EBS and you're using it with a provisioned IOPS volume, and you also have a bunch of network traffic going to your instance from another location, then there's a chance that that traffic may interfere with the throughput between your EBS volume and your EC2 instance, right? So what an EBS optimized instance allows you to do is to get that dedicated throughput so that it's not impacted by any other traffic you have going to your instance. So while you can use and we have a number of customers using provisioned IOPS volumes with instances that are not EBS optimized, the guideline around the level of consistency that we provide, which is you should see within 10% of the IOPS that you provision 99.9% of the time, will really only apply to when you're using an EBS optimized instance. Another question was to explain the concept of warming up a volume. So when you think about the consistency of a provisioned IOPS volume, it assumes that you've already gone through and either read or written every chunk of data in that volume. So it is important when you're creating a brand new volume that you go ahead and you read and write all of the data on that volume one time. Just so that you warm it up, and from then on you will get the consistent performance. So as I mentioned as an example, if you're running a benchmarking application, run the benchmarking application once on the volume, and then go ahead and run it for real. If you plan to use the volume in production, go ahead and read and write all the chunks on that volume first, and then go ahead and deploy the volume into your production system.
Somebody asked that we mentioned replication and failover, and what about active-active configs between AZs, and if we support it. There's actually customers, our AZs are controlled with the API. You can launch Heiio instances or any kind of EC2 instances, even if you're running an EBS-backed, EBS-based database, and run an active-active configuration between AZs. And in fact, we have several customers running Cassandra across availability zones today. If you look at the Netflix presentation, you'll see exactly how they do that, because that is how they run Cassandra on EC2.
So another question was whether an existing EC2 instance can be upgraded to an EBS optimized instance. And yes, we do support APIs for modifying the instance to be an optimized instance.
Yeah. I mean, I think the key to that question was there's two aspects to it. You have EBS volumes, and you can provision IOPS on the EBS volume, and you can use it with a standard EC2 instance and an EBS optimized instance, and you'll get the best performance if you have an EBS provision IOPS volume and an EC2 EBS optimized instance. That's what will give you your best performance. Please keep asking questions. There's a lot of questions coming in. So.
So another question was how you can see the performance that you're getting from your provisioned IOPS volume. So as I mentioned, we do integrate with the Amazon CloudWatch service for both EC2 and for EBS. So with standard volumes, you can see metrics like I/O throughput, queue depth on a 5-minute period, and for our provisioned IOPS volumes, we're now delivering these metrics on a 1-minute period basis. So you can go in and see the, I mentioned a few things around optimizing your volume, right? So one of them was queue depth. So you can go into your Amazon CloudWatch console, or you can see this from the EC2 console as well. Click on your volume and you'll be able to see the queue depth over time on a 1-minute period basis. You'll also be able to see the I/O size. So I mentioned I/Os of 16 kilobytes or less is how EBS handles the IOPS that you've provisioned, and you can see that on the CloudWatch console as well. And you can also see the throughput that you're getting, so the number of IOPS that you're getting from your volume, and you can see the consistency at which you should be getting those IOPS using the CloudWatch console. So there's another question on how to convert a standard EBS volume to a provisioned IOPS volume. So the way you can do that is by taking a snapshot of your standard EBS volume, and then you can create a new provisioned IOPS EBS volume from the snapshot that you've taken. Another question was whether customers have used Postgres with EBS provisioned IOPS. And actually, yes, I can say that we actually have seen a number of high I/O workloads since the time we've launched that are focused on Postgres with provisioned IOPS.
And somebody had asked a similar question related to the high I/O volumes. Yes, we have. We have seen some, at least 1 or 2 customers running Postgres on the high I/O instances. It's not as common as Cassandra or Mongo or some other systems that we have seen, but definitely, based on what we know, we have definitely seen at least a couple of customers doing so. So there's a question on EBS optimized instances and how they apply to reserved instances for M1 large and M1 extra large. If you have an M1 extra large or an M1 large reservation, all you need to do is relaunch the instance with the appropriate EBS optimized flag, and we will honor your reservation. There's a small chance of an insufficient capacity error when that happens, but it's very unlikely. So you don't need to purchase a new reservation for those.
There was another question around pricing of provisioned IOPS volumes compared to standard volumes and how to think about the cost between the two. And really, what we've done is we've priced in a way such that if you're running an I/O intensive workload, you should find that it's actually cost effective, more cost effective to run a provisioned IOPS volume than a standard volume. So that's one way to think about the pricing distinction. And Jeff Barr recently, our AWS evangelist, wrote a blog post for additional resources with regards to provisioned IOPS volumes. So please go to our AWS blog and you can see his blog post. One of the resources that he highlighted really talked through how to think about pricing between provisioned IOPS volumes and standard EBS volumes.
Somebody just asked if the Amazon Linux AMIs are optimized for using with IOPS. I'm not sure whether it's related to EBS or to the high I/O instances, but in general, we try and make sure that the Amazon Linux AMIs are tuned to run well on EC2. And if you have any issues with them, we'd definitely like to hear. But we have customers running other operating systems as well and getting really good performance. So it depends. If you're using a modern kernel and a modern OS, you should be fine.
So another question was whether the bandwidth capacity of an optimized instance applied to all the EBS volumes attached to that instance, or just each one individually. So it's the way to think about it is, let's take the M1 extra large as an example. You're getting 1,000 megabits per second dedicated throughput between the instance and all of the volumes that you've attached to that instance. So it's not, let's say I've attached 3 EBS volumes to that instance. I'm not going to get 3,000 megabits per second total throughput. Instead, I'll get 1,000 megabits per second dedicated throughput between the instance and all 3 volumes combined. There was another question around what's the most number of IOPS that you can provision for your AWS account. So today, by default, you can provision up to 10,000 IOPS from your EBS volumes for your AWS account. And we actually have a request form on our website you can access from our FAQ page, and you can actually request an increase in the number of IOPS that you want to provision for your AWS account. So again, just to recap, you're currently limited to 1,000 IOPS per volume, but we plan on increasing that limit over time. We find that a number of customers are striping across multiple volumes to deliver thousands of volumes to their EC2 instance, and each AWS account is by default limited to 10,000 total provisioned IOPS, but you can go to our website and fill out a request form to have that limit increased.
Yeah, so the default limit for the SSD instances, there's a question on the limit being 2. For now, we'll keep the default limit at 2. You can definitely ask for more by going to the EC2 Instance Limit Request page. We have seen pretty extraordinary demand for these instances, and we are busy ordering more so that we can satisfy all the requests coming in. If you do have needs, please do submit your request, and we will try and accommodate it. If you're having any issues, do reach out to us. Over the last week or so, we've definitely started accommodating a lot more larger requests that have been coming in, but we are still seeing extraordinary demand, so we are continuing to work to alleviate that particular problem. Somebody just asked a question on HI1 instances in US West 2 and other regions. I mentioned this earlier, so we are continuing to look at which other regions to expand to, and over the next several months, we'll expand to other regions. If you have any specific interest in a particular region, please do reach out to us or to your account manager and let us know what your particular interest is, and we will definitely take that into advisement. Everything that we've, there was a question if Provisioned IOPS volumes, EBS optimized instances, and high IO instances work in the virtual private cloud, and the answer to that is yes. Everything that we've talked about today works inside of VPC as well.
So another customer asked about whether we suggest running IOPS volumes what type of RAID do we recommend for running applications on provisioned IOPS volumes? So running for example RAID 0.
Just real quick, running RAID 0 is absolutely recommended on top of the provisioned IOPS volumes, and frankly any EBS volume system, as well as the volumes local to the Heiio 4XL instance. RAID 0 doesn't provide any kind of smoothing of performance, reduction in sort of peaks and valleys. If anything, RAID 0 drags the performance of the fleet of disks to the lowest common denominator of the volumes made up that create that RAID. So provisioned IOPS at the 1,000 IOPS level or lower, you don't need RAID to deliver consistent performance at 500 IOPS or 600 IOPS or 800 IOPS anymore. You can use a single EBS volume to do that. And there's no advantage to using multiple volumes and rating them towards achieving that kind of performance. If you need above 1,000 IOPS, that's where RAID 0 starts to become a viable alternative.
And again, just to add to that, so really the value of RAID 0 with provisioned IOPS is, as mentioned, because it's performing at the performance of the lowest, the least performing volume. Because provisioned IOPS are providing that high level of consistency, you then ensure that even your lowest performing volume is still providing at a consistent level compared to what you provisioned for that volume.
Yeah, as people continue asking this question, so I'll repeat the administrative comment that we made earlier. We will be making the video a recording of this presentation and the slides available, hopefully, over the next few days. Just going through the questions, there's a lot of questions coming in. Give us a few seconds. Yeah, so there's a question on the EC2 SLA. I recommend going to the EC2 detail page. We have SLA related to the availability of the API, which you can read about there in the terms of service and more about how EC2 functions.
There's a question that came in. Question that came in regarding the ability to change to provisioned IOPS immediately or while a device is active. So a snapshot moving from a standard EBS volume to S3 for backup and then recreating that volume on a provisioned IOPS volume is the only method to move on to the provisioned IOPS system. So there isn't a way to enable provisioned IOPS on an existing EBS volume. You do have to create a new volume. Differently than that, the EBS optimized flag is a flag that can be set on an instance using the modify instance attributes API or the management console. That means that during a stop-start cycle of an EC2 instance, you'd be able to take the same instance and enable EBS optimized. So similarly, as a previous question, the reserved instance system applies, and you'll easily be able to take a machine and enable or disable EBS optimized status on a given reserved instance.
I think with that, we are coming to the end of our time. We definitely have a lot more questions, and we'll try and reach out to you after the fact, or if you can reach out to us through the support forums or through your account contacts. We're happy to answer more questions. I hope this webinar helped you understand how you can use high I/O instances or EBS provisioned IOPS volumes more effectively for your database needs. And we're continuously interested in providing more features that will help people run databases on EC2. With that, we'd like to thank you for your time. Once again, you'll see the video and slides on the website very shortly, and you can reach out to us after that as well if you have clarifying questions. Thank you very much.